I'm Jing Xuanzhang from Nanjing University of Aeronautics and Astronautics in China. I will introduce a new method to enrich API documentation with code samples and usage scenarios in this presentation. This work has been accepted by TSE. As we know, reusing APIs in existing libraries could speed up software development process. When facing an unfamiliar API, developers often consult API documentation. However, developers are willing to learn API usage in the context of code samples rather than only read verbose description. Hence, it could be ideal if API documentation can be automatically enriched by code samples and usage scenarios. We propose a novel approach, a DAC, leveraging crowd knowledge from Stack Flow to identify code samples and usage scenarios for enriching API documentation. It consists of 6 components. The first component is API type Extractor. It identifies and extracts API types from API documentation. The second component is question and answer pair search engine. It generates a series of question and answer pairs from Stack Flow and links them to related API types. We employ the traceability linking method in this figure to link question and answer pairs to relevant API types. After obtaining the linked question and answer pairs, question and answer pair preprocessor extracts usage scenarios and code samples from the linked question and answer pairs for each API type and combines them into usage scenario and code sample tables. The next component is tuple clustering. It clusters usage scenario and code sample tables for each API type to avoid duplicate tables. Tuple representation selects the most representative usage scenario and code sample tables, achieving the highest user score from each resulting cluster. Finally, information embedding embeds the top-ranked representative usage scenario and code sample tables into API documentation. We define a template to organize these tables for API types and embed them into API documentation. We investigate 4 research questions in this study. First, we investigate the quantity of the API types illustrated with code samples in the DAC-enriched API documentation. Second, we investigate the quality of the enriched code samples for commonly used APIs with 3 quality indicators, including correctness, conciseness, and usability. Each code sample is evaluated by 2 volunteers on a 5-point Lecter scale. Next, we explore the coincidence levels between code samples and usage scenarios in the DAC-enriched API documentation. Finally, we investigate whether the DAC-enriched API documentation can boost the productivity for developers. We invite 21 developers and divide them into 3 groups. They are required to accomplish some programming tasks with the help of different types of API documentation. This table presents the number of API types illustrated with code samples in 3 types of API documentation. Here, Xdocs is a baseline approach. As shown in this table, the number of API types illustrated by code samples is greatly improved in the DAC-enriched API documentation. The 2 figures show the average evaluation scores on the quality of the code samples in the Xdocs-enriched and DAC-enriched API documentation. We can see that the quality of the code samples in the DAC-enriched API documentation is higher than that of code samples in the Xbox enriched API documentation. This figure shows the frequency histograms for the coincidence levels between usage scenario and code samples in the DAC enriched API documentation. The average scores are about 4 on a 5-point Likert scale. It means that the code samples are relatively consistent with the corresponding usage scenario. The results of RQ4 are presented in this figure. We compare different programming tasks, different developer groups, and different types of API documentation. Especially, we can see that the task completion frequency of the DAC enriched API documentation is the largest, and its average completion time is the shortest. It means that using the DAC enriched API documentation, developers can complete more programming tasks within less time. Okay, thanks.